do it. Okay, so today we have something fun. It's integration by substitution. So last class we learned about just normal integration and antiderivatives. Today we get a little crazy. So if you guys remember the chain rule was if you took the derivative of a composite function, so a function made of multiple functions, the chain rule gave you the derivative of the outside times the derivative of the inside. Well, now we are going to reverse that process by using antiderivatives, by using integration. So the substitution rule is going to make a difficult integral into a much easier integral that we can find the antiderivative of. Okay, so here, this says the integral of f prime of g of x times g prime of x. So basically, the integral of the chain rule. If we let u equal the inside function g of x, so this is u, then we come out with an easier integral as the integral of f of u du. And once we find the antiderivative, we'll end up with f of g of x plus c. So again, we are reversing the chain rule. So we end back here. Okay. And again, try not to make it too complicated with all this notation. We're going to use a bunch of substitution today to make our antiderivatives much easier. And the way to do this is by choosing the more complicated part, looking part of the integral to be our substitution. And it's all definitely trial and error. Okay, so let's go ahead and try this out. Number one, we have the integral. Oh, I don't need that much space. Okay, we have the integral of 2x cubed minus 3 to the fourth times 6x squared dx. Now we're going to do a substitution. So we want to do it on the more complicated part. What looks more complicated? 2x cubed minus 3 or 6x squared?
So it's 2x cubed.
So this is going to be our sub. We're going to let u equal 2x cubed minus 3. So I'm going to handle that over here. I'm going to say sub. So u equals 2x cubed minus 3. Okay, and now what we're going to do with our substitution is we're going to take the derivative of our substitution. So we're only looking at this side right now. So we're going to say du, and we have to use some proper notation here. We're going to say du over dx is equal to the derivative of 2x cubed, which is 6x squared. And of course, the derivative of 3 is 0. Okay. Now, what we're going to do on the substitution is multiply this dx to the right side. So we're going to end up with du equal to 6x squared dx. Okay. Now, let's leave that alone for now. We'll come back to that in a second. Now, since we made the substitution, let's see what's going on the actual integral. So this now becomes the integral of u to the fourth times 6x squared dx. Now, I want you to look at this integral, and I want you to look at our substitution and tell me, do you notice anything similar? There's a 6x squared dx here. Do I have a 6x squared dx on my substitution?
Yes.
Yes. So these match up, which means 6x squared dx just becomes du. So what we're left with is the integral of u to the fourth times du. There you go. And now we have an easier looking integral. This looks way better than what we started with. And now all we have to do is find the antiderivative. So we're going to use the power rule here. So this will become, I'll rewrite it down here. The integral of u to the fourth du will become u to the fifth over 5 plus c. And now we're almost done, but we have to resubstitute for the value of u. Well, remember that u was all of this, 2x cubed minus 3. So we're going to plug that in. So our final answer is going to be 2x cubed minus 3 to the fifth over 5 plus c. That's it. It's a little crazy, but it's not bad. Any questions on that?
So what do we do with the 6x squared and the dx? Is that part of the sub?
That's part of the substitution. So our job is to make a substitution to replace certain parts in the integral to create a easier integral. So 6x squared dx became du. And that's all we needed it to do. And we don't do anything else with it. Okay, so it's like a sub, more substitution, and more substitution. Of course, we have more examples till we hopefully get the hang of it. But everybody good with this one?
For now.
Yes.
For now, good. All right, let's try another. 2, the integral of 1 over 4x plus 7. What looks more complicated, 1 or 4x plus 7?
4x plus 7.
Definitely 4x plus 7. So this is going to be our sub. We're going to let u equal 4x plus 7. So again, I'll handle it over here. U equals 4x plus 7. Take the derivative. Du over dx is equal to 4. Multiply that dx to the right side, and you get du equals 4 dx. Okay, and we'll come back to that. So now, here's what our integral looks like. The integral of 1 over u dx. So we need to make a substitution for this dx. Well, if you look at the right side, we have du equals 4 dx. How do I get this dx all by itself? What would I divide by?
4.
4. You divide by 4, and du over 4 now equals dx. And now does this dx match up with this dx?
Yes.
Yes.
Which means that dx now becomes what?
Du over 4.
Du over 4. And again, one of our goals here is to put everything in terms of u. So if we do this by substitution, the integral becomes a lot easier. So now, based on our substitution we just did, this whole integral is in terms of u. You have 1 over u, and you have du. So all we have left to do is clean this integral up. Okay, so what I'm going to do is take out the 1/4. There's a fraction of 1/4, so this will be rewritten as 1/4 times the integral of 1 over u du. And all I did was take that fraction out. Okay, now we are ready to find the antiderivative. And remember from your integration rules or formulas from last class, the antiderivative of 1 over u is the natural log of the absolute value of u, and then plus that constant. Okay, but again, we have to plug u back in. So this means that 4x plus 7 is going back in for u, and then we're done. So you get 1/4 times the natural log of 4x plus 7 plus c. There we go. Any questions on that?
So whenever we separated on the substitution part, the 4, you divided it by both sides. That's why you continue it on the left side with adding it on, right?
Exactly.
Okay.
All right. What else, guys? Does it feel a little bit too tricky? Okay. Of course, more. 3. The integral of x squared times e to the x cubed dx. All right. So here's what we're gonna do. Okay. What looks more complicated, x squared or e to the x cubed?
E to the x cubed.
E
Question
to
though,
the
real
x
quick.
cubed. What's up?
So whenever you select the substitution, it's always going to be from what you think is most complex.
Exactly.
Huh.
But
Isn't
again,
there- yeah.
it's all for you guys, it's going to be all trial and error.
Okay.
So let's say that you're like, well, you know what? I want to choose x squared this time.
Yeah.
And if you're like, okay, so you choose x squared, you take the derivative, you get 2x dx. And then now you basically want to just isolate your x's and your dx's by themselves. So you
Okay.
would get du over 2 equals x dx, which means now you would check to see if there's an x dx on the integral over here. But do you have an x dx anywhere?
No.
No, you wouldn't, right?
No.
Because if I wrote in this substitution, you'd have u times e to the x cubed dx. And if there's an x dx here, we need one over here. Do you see one?
No.
No. So those wouldn't match up, meaning we have to select another substitution. So again, it's all trial and error. Students are like, how will I know? Like, how do I know? I'm like, that's for you. That's you as the student. It's trial and error. You figure it out. And if you just can't, then you ask me. All right. So for this one, yes, e to the x cubed looks more complicated, but what I'm going to do here is just let u equal the exponent. And again, the reason I'm doing this is because trial and error. Even if you let u equal the whole thing, you're still going to get it right. But it's going to be a lot easier if we just let u equal x cubed. And now we're going to say du, and we're going to skip one tiny step. I'm going to put the dx on the right side already. So we're going to have the derivative du equal to 3x squared dx. You guys okay with that? We're just skipping that tiny step of putting it here and then multiplying it to the right. We know it's going to go on the right all the time, so why not just put it there already? Okay, so let's pause there for a moment and let's look at what we have so far in the integral. Here, we now have the integral of x squared times e to the u dx. I'll even put times there. Now look at this integral and look at our substitution. Do you notice anything that looks common?
X squared,
And what else?
dx.
Dx. Do I have an x squared and a dx here?
Yeah.
Those look common, which means let's go ahead and get x squared and dx by itself on our substitution. This means we're just going to have to divide this one by what number?
X? Oh, 3.
By 3. Because once again, you want your x's just on this side. So du over 3 now equals x squared dx. So what I'm going to do here is rewrite this integral as e to the u times x squared dx. And now this x squared dx matches that x squared dx. So now on our integral, x squared dx now becomes what?
1 x dx.
X cubed.
X squared dx becomes,
3.
it becomes
du over 3.
du over 3. That's all by substitution. We're doing nothing but substitutions. So since those x squared dx match up, we're now saying that x squared dx is du over 3. And all I have left to do is take that 1/3 out, and it gives me the integral of e to the u du. And lucky for us, the antiderivative of e to the u is still e to the u. And all we have left to do again is plug in x cubed for that u, and we're done. So we get 1/3 e to the x cubed plus c. There you go. Any questions on that?
So what happens to the du?
So remember that is the du is the it's telling us what we're taking the integral with respect to. So when it's the integral of eu du, we are going to say we're taking the integral of e to the u with respect to u. It would be the same as me saying the integral of x dx. I would say I'm finding the antiderivative of x with respect to x. So that dx is just a notation stating what are we finding the antiderivative with respect to.
Gotcha.
It's kind of like saying the derivative. If I said d over dx of x squared, we would say we are taking the derivative of x with respect to x. So they are just notations that we need. Make more sense?
Yeah.
Okay. Everybody good on that one? All right. More to come, right? Okay. 4. Integral of 4x squared times the square root of x cubed plus 5. What looks more difficult, 4x squared or x cubed plus 5?
X cubed plus 5.
There's our u. Sub u equals x cubed plus 5. And now du equals 3x squared dx. Okay. And now, like I've been saying, we can actually fix this now because we just want the x's by themselves. So let's go ahead and just divide that 3 off. Du over 3 equals x squared dx. Now let's come back to our integral and see what we have. So right now I have the integral of 4x squared times the square root of u times dx. Now look at our integral and look at our sub. What do they have in common?
X squared and dx.
X squared dx. X squared dx. Okay. So this means that, let me do a quick rewrite. I'm going to pull this 4 out and rewrite this as 4 times the integral of the square root of u times x squared dx. And now, does this x squared dx match up with this x squared dx?
Yes, sir.
Now, what does it become by the substitution?
Du over 3.
Du over 3. There we go. So we get the integral, 4 times the integral of the square root of u times du over 3. All right. Now we got to clean up. So we have a fraction of 1/3 in there. So I'm going to take out the 1/3. So this is going to be 4/3 times the integral. And then the square root of u, I'm going to rewrite as u to the 1/2 du. Okay. This integral is all set up and ready for us to find the antiderivative. So we're going to be using power rule again. The most
Question.
popular rule. What's up?
How'd you get to the 4 over 3?
What fraction did I take out over
You
here?
said 1 over 3, right?
Yep.
Where are you grabbing that from? I'm just kind of confused.
So du over 3 is the same as 1/3 du.
Okay, okay.
And if I
That's what-
move it to the front, 4 times 1/3 is 4/3.
Okay.
Good.
Makes sense.
Good question. No, those are good. It's all those algebra tricks, right? Okay. Now we are using power rule. And since it's a fraction, I'll help you guys out. That's u to the 1/2 plus 1 over 1/2 plus 1. All right. And now we have to clean up. So you get 4/3 times and 1/2 plus 1. That's 50 cents plus $1, or that's u to the 3/2 over 3/2. And what do we do with this fraction down here?
Flip.
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 There you go. Who they want? They want flip. Okay. He's everywhere. Okay. So 2 goes to the numerator. And you get 2u to the 3/2 over 3. Now multiply straight across. And we get 8 over 9 u to the 3/2 plus c. Almost done, because now we have to plug back in u. And what was u?
X.
X cubed plus 5.
Good. To the 3/2 plus c. There you go. Oh, and of course, if you ever wanted to check your work, you would just take the derivative and see if it gets you back to the original problem. All right.
I don't know what's prettier, the question or the answer on that one.
the answer is definitely prettier. Oh, what was that? All right. Okay, let's keep going. All right, 5. Do it again, do it again. The integral of x over x squared plus 1 squared. Who looks more complicated, x or x squared plus 1?
The bottom
Definitely
one.
that. There you go. So sub u equals x squared plus 1, du equals 2x dx. And then here it's fine. We can divide by 2 and get x dx by itself. Okay. Now, let's see what we have. We've got the integral of x over u squared dx. Now, what looks common?
The dx.
The x and the dx. The x and the dx, right? But of course, I'm going to rewrite it so we can see it better. I can rewrite this as 1 over u squared times x dx. And now this x dx matches that x dx and becomes what?
du over 2.
Over 2.
du over 2. Good. Times du over 2. Now, some cleaning up to do. What fraction can I pull out?
A half.
1/2.
The 1/2. And you get 1/2 times the integral. And this u squared, I'm going to flip up and make it u to the negative 2 du. And now we are all set to find the antiderivative. You'll get 1/2, and this is going to be power rule. So that should just give you u to the negative 1 over negative 1. Multiply straight across, and you get u to the negative 1 over negative 2 plus c. Okay, but now you plug in u, and what was u?
X squared plus 1.
Good. X squared plus 1 to the negative 1 over negative 2 plus c. That is a decent answer. Or, since I hate negatives in the denominator, I can also rewrite this as negative 1 over 2 times x squared plus 1 plus c. But like I said, the first one's fine as well. All right, any questions on that one?
I have a quick question, I think.
Go ahead.
On the second part of that, where you got the 1 over u2 times x dx,
Mhm.
how did we get to that point where you said you're going to pull out 1/2? Is it the same thing as since there's a 1 over u to the second power?
How do we get here to
Yeah.
here?
Uh-huh.
So what I did is I rewrote this one to make it look like that.
By doing what?
By just splitting the fraction apart. So if I have, let's just say I have x over u squared, right?
Yeah.
Another way to rewrite this is x times 1 over u squared.
Okay, yeah. Okay.
Or like I wrote it, 1 over u squared times x.
Okay, so when you take that x off, you're just going to throw it to the right side so it can be x dx?
Exactly. And the reason I'm writing them like that is so you can actually see the substitution going on. So they
Okay.
match up.
Okay.
There you go. Yeah, it's kind of like if I said, all right, I have, what could I say? If I had x over 3, it's the same as me saying 1/3 x.
Yeah.
Yeah. So,
Okay.
yeah. So just little rewrites. Okay. Next. Okay, so for these ones, sometimes we can't express the integral all in terms of u. So in order to do so, we're going to have to take our substitution and make another substitution out of it. So we're going to get real Inception movie-like. So we're going to get our substitution and make another substitution. Okay. So for 6, we have the integral of 5x minus 7 times x minus 1 to the 4th. So who looks more complicated here?
5x minus 7.
We would think that, but it's actually going to be x minus 1. And the reason for that is because x minus 1 is raised to the what power?
4th.
4th. So this is the actual more complicated looking one. So u is going to equal x minus 1. Okay. So here is our sub. You get u equals x minus 1. This means that du equals 1 dx. Okay. And now let's look at our integral. Here's what we have. We have the integral of 5x minus 7 times u to the 4th dx. Okay. Well, one thing we know already is that we can make a substitution for dx. I have a dx here and I have a dx here, which means dx is just going to become what?
Du.
Du. So these match up. So my next rewrite is the integral of 5x minus 7 times u to the 4th du. But now we have a problem because we need to make this integral all in terms of u, and this x is messing everything up. So we have to get rid of that x. And the only way to do so is to take our original substitution and solve it for x. So here's what we're going to do. Go ahead and take this, u equals x minus 1, and solve this equation for x, which means all I have to do is add what number to the left side?
1.
1. We get u plus 1 equals x, which means that all of this is going in for that x there. So here's what we have. My new integral is now the integral of 5 times my new x value of u plus 1 minus 7 times u to the 4th du. You guys see what I did there?
Yes, sir.
Here, I can now draw this arrow here. Boop. There we go. Okay, now we just have to clean this up. You're gonna distribute that 5, and we get the integral of 5u plus 5 minus 7 times, times u to the 4th du. Still more cleanup. We got to put that 5 and 7 together. And we get the integral of 5u minus 2 times u to the fourth du. Almost there. Distribute this u to the fourth. And you'll get the integral of 5u to the fifth minus 2u to the fourth du. And now we are set to find the antiderivative. Okay, which means on both of these, they will use power rule. So let's go ahead and look at the first one. I can zoom in more. There we go. So now for the first one, 5u to the fifth, you're going to get 5 times u to the 6 over 6. Minus, for the second one, you're going to get 2 times u to the fifth over 5. And then clean this up. You get 5, 6, u to the 6 minus 2/5 u to the fifth plus c. And all we have left is to plug in u. What was u?
X minus
1.
1 to the fourth.
X minus 1. So here we go. Final answer. 5, 6 times x minus 1 to the 6 minus 2/5 times x minus 1 to the fifth plus c. Yeehaw. Sub within a sub within a sub. Any questions on that process?
No, sir.
Just taking it in, right? Okay, let's try it again then. All right, 7. Integral of x over the square root of x plus 2. And of course, x plus 2 looks more complicated. So for our sub, we get du equals, nope, not du, just u equal to x plus 2. Du will equal 1 dx. Okay. Now, let's look at our integral. Let's see what we have here. We get the integral of x over the square root of u dx, which means we can already make a substitution. This dx and that dx match up and will become what?
du.
Du. So you get x over the square root of u du. But once again, we have this pesky x that we need to get rid of. So this means that we look at our substitution again. U equals x plus 2. Now, once again, all we have to do is solve this equation for x. Oh, I should move that, huh?
U plus 2.
U
minus 2.
minus 2. There we go. And now this is going in for that x. So now we have the integral of u minus 2 over the square root of u du.
We take out the -2.
We cannot, because it's not connected by multiplication.
Do we
So
just
that u, yeah, that u minus 2 has to stay as u minus 2. If it was 2u over the square root of u, then yes,
Gotcha.
you can take out that 2.
Gotcha, because it's a sub, so you can't separate it.
Well, not because it's a sub. It's because now we're talking algebra. If it's u minus 2, I can't disconnect those. They are connected by the subtraction operation. The only way to separate them, because we're going to have to, is by, again, algebraic manipulation. So we can't take the 2 out, but we learned this last class that I can split this integral into 2 separate fractions. So remember that last time we had something like x squared plus x over x to the 4th. I was able to rewrite it as x squared over x to the 4th plus x over x to the 4th. Guys, remember that? That is the only proper way in how to separate them. They have to be over the same denominator. So I'm going to rewrite this as the integral of u over, and the square root of u now needs to be rewritten as u to the 1/2 minus 2 over u to the 1/2 du. We have just split it into 2 separate fractions. We haven't done anything wrong. And now we must simplify. We're not even ready for the antiderivative yet. So u over u to the 1/2. Remember that if you have the same base, you subtract your exponents. Well, 1 minus 1/2 is 1/2. So that first term becomes u to the 1/2. Minus, and then what we're going to do on the second term, all we're going to do is take this u to the 1/2 and flip it up using the negative exponent rule. So we get minus 2 u to the negative 1/2 du. Everybody good with that manipulation so far? Subception. Just saw that. Nice. Okay. Which means we are now ready for the antiderivative, and both of these will use power rule. Okay. So there it goes, zoomed in enough. For the first one, since it's a fraction, I'll help you out again. You get u to the 1/2 plus 1 over 1/2 plus 1. That's for the first one. Minus 2 times, and again, power rule with the fraction. U to the negative 1/2 plus 1 over negative 1/2 plus 1. And now clean up. We learned that last time this gave me u to the 3/2 over 3/2 minus 2 times, well, negative 1/2 plus 1, negative 50 cents plus $1. That's a positive 50 cents over 50 cents. And then we will flip. And we end up with 2u to the 3/2 over 3 minus 2 times 2u to the 1/2. And C is almost there. We get 2/3 u to the 3/2 minus 4 u to the 1/2 plus C. And what was u?
X plus 2.
X plus 2. All right, so here's our final answer. 2/3 times X plus 2 to the 3/2 minus 4 times X plus 2 to the 1/2 plus C. Done and done. Woo. Questions on that one?
I have a question.
What's up?
Before we got to the antiderivative part, whenever we were rewriting it at the end, how come it wasn't u to the negative 1/2?
On which part?
Where we were rewriting it before we started the antiderivative, where it has the integral.
Like this part?
Yeah.
So remember that it's subtraction. So u over u to the 1/2. This means that it's u to the first minus 1/2.
Oh, okay.
And 1 minus 1/2 will give me u to the 1/2.
Okay. Got it.
Yeah, good. You see how much algebra exists in calculus? It's insane, right? Okay. Last one. All right. Number 8. The integral of x times the square root of x plus 1. And of course, we know that u is going to belong to x plus 1. U equals x plus 1. Du equals 1 dx. Let's see what we have on our integral. We now have the integral of x times the square root of u dx. We know that this dx and that dx match up. So we are left with the integral of x times the square root of u du. And once again, we have to get rid of that pesky x. So we go to our sub. And let's do that here. U equals x plus 1. Move that 1 over. And u minus 1 equals x. Which is going to go in to here. So now we have the integral of u minus 1 times the square root of u, which I'm going to rewrite as u to the 1/2 du. Okay. It's now all in terms of u, but we have to simplify algebraically. So you're going to distribute it to both of these terms. All right. And now u times u to the 1/2. So what that looks like is u times u to the 1/2. Now remember, the same base, you add your exponents. So u times u to the 1/2 will give you u to the 3/2. minus, oops, the integral of u to the 3/2 minus u to the 1/2 du. Okay, this is all set. We are ready for power rule on both of these lovely fractions. So we'll start with the first one. You get u to the 3/2 plus 1 over 3/2 plus 1. Minus, we'll go to the second one, u to the 1/2 plus 1 over 1/2 plus 1. Okay, clean up. We get u to the 5/2 over 5/2 minus u to the 3/2 over 3/2. And what do we do with these fractions?
Flip.
Flip. Flip, flip, Philadelphia. All right. So you get 2u to the 5/2 over 5 minus 2u to the 3/2 over 3 plus c. But what was u?
X plus 1.
X plus 1. So we get 2/5 times x plus 1 to the 5/2 minus 2/3 times x plus 1 to the 3/2 plus c. Done and done. My goodness. Any questions on that?
Jesus.
Maybe he'll be able to help you.
Well, I got a
Alright.
lot of questions. Just I'll ask them later. I'll look at it later.
Yeah. I mean, you see there's just a bunch of algebra involved, bunch of substitution. You just keep track of all your steps, or else it could get real messy. But again, it's all trial and error. What do you substitute for? How do you know what to substitute for? Just pick something. And if it doesn't work out, choose something else. So all trial and error.